the first process of dyeing fabric is the cleaning part of it and the initial prep. So the first thing you want to do is scour your material, and this is true for any type of fiber that you are dyeing. What you would do is, if you're dyeing something like yarn, you would wind it into a skein, makes it nice and easy. That way any water or cleaning products can access every single part of the fiber. So the first thing you're going to do is take a giant pot, put some type of dish soap in it. I usually use Dawn just because it works best at getting any of the grease out. And you're also going to add washing soda. From there, you are going to bring it up to a simmer, and you are getting off any oils, any dirts, any sort of treatment that the fiber may have, whether it's natural or man-made. You're getting all of that off of the fiber itself. After that, what you're going to do is you're going to need to mordant your fabric. Now, this is a process that lets you chemically bond the dye to the fiber. Dye does not chemically bond to fiber itself. That's why we are able to use things like laundry detergent to get stains out. When you add a mordant, you are adding a metallic salt that is chemically bonding to the fiber. The dye is then chemically bonding to the mordant, and from there, you are not going to lose whatever color you made. I typically use alum. That is one of the most common ones. That's also what's used historically for the most part. And I, in particular, use aluminum sulfate. There's different types of alum you can get. That's just the easiest for me because it is a canning ingredient, and I can buy it in bulk for fairly cheap. So once you have your alum, you are going to follow some sort of recipe. There's different types for different fibers. You add that, and you are basically going to boil your fiber in it. And this is true for protein fibers and cellulose fibers. So it's true for wools, silks, cottons, and linens. You're not going to be able to dye any sort of man-made fiber because of the way it is made. Alright, so at that point, the prepping of your fiber is done. So at this point, you should have some fiber that is chemically changed. And from here, you can let it dry. It can dry as long as it needs to. You can let it sit out for days, years, or months. It is no longer going to change. You are not going to be able to wash out that mordant. You're not going to be able to bleach it out. It is permanently changed. From there, you get to the fun part of adding colors. So there's two main types, one that needs a mordant and one that doesn't. These ones are called substantive dyes, and these have that sort of chemical in them already. In this case, this is made of indigo, but black walnut is also a substantive dye. Anything with tannins, so dyeing with things like acorns, any type of walnut, most nuts, a lot of tree barks are going to not need a mordant. Things like this, which is most of the other dyes, are going to need a mordant. So these dyes don't need a mordant. These are going to be a little bit more reactive. These also probably aren't going to last as long in the sun or with washing. That being said, they do last a really long time. This one was dyed with goldenrod. Again, this needs a mordant. If I did not mordant this fabric, it would have been a very light gray color. The dyes that I have in front of me are all considered New World dyes. So one of the first ones that basically took the world by storm is logwood. And that is because it gives you a true purple, and it is fairly easy to accomplish. It is done like most other dyes. You are not needing anything special like a vat dye. And again, it gives you a very nice purple color. This is goldenrod. This is also a New World dye. It gives a very nice yellow color. And this is what would have been used mainly by home dyers. Industrial dyers would have been using something called weld. It gets you the same color. It's a little bit easier to achieve on a mass scale. For this, you need a lot of flowers before you're actually getting a very saturated color. This is black walnut. This is also a New World dye. So while different types of walnuts did exist in other parts of the world, black walnut gives one of the darkest dyes and one of the most color-fast dyes. And this is because of two different compounds in the black walnuts. This is because of both jugalone and tannins. Tannins help the color stay, jugalone is the color itself. So you're able to achieve super dark browns and super rich browns with very little dye material. This is also super common among home dyers, especially on the frontier. So these are both different types of old world dyes. And by old world, I mean very, very old world, to the point where we don't know where these dyes originally were native to. So this one is indigo. This can come from multiple different plants. What's actually being used is a compound called indigotin, and this is both in different types of indigo, different species, as well as in plants like woad. The biggest difference is going to be the concentration of the dye compound in the plant itself. Indigo is also a very weird dye in that you have to treat it a very specific way that is very different from almost any other dye. You have to do what's called a vat dye, meaning you are fermenting it and you are basically making a gross bucket of dye stuff, and from there you are able to dip your fibers in it and get one of the most light, fast blues ever. This is used in absolutely everything. If there is a blue color historically, it's most likely coming from indigo. And this is in painting, this is in textiles, this is even in some hair and makeup products. This is from a dye called madder. This is another old world dye because, again, it is so old we don't know where the plant is native to. Its Latin name is Rubia tinctora, and I say Latin name, not scientific name, because that is what it was known as in Rome. There are traces of this found in Pompeii. There are traces of this found in King Tut's tomb. This is absolutely everywhere throughout history. This is the same red that is making British redcoats. This is the same red that is making Turkish fezzes. This is the exact same red. If you see a scarlet red, it is almost exclusively coming from the madder plant. With this plant, this is something you do have to cultivate. You are not able to get the dye from the plant for at least 3 years, and the older the plant, the stronger the dye.